So before we get started, can people have a show of hands? How many people consider themselves savvy Python people, like ready to use Python, happy about it? How many people consider themselves kind of Python newbies, used to some other language but trying it out? Okay. How many people are well-versed in the SciPy and Python for data science stack? Like you use all the tools, use pandas, use stuff. Okay. How many people have used matplotlib? Either pandas.plot or however. Okay. All right, that's a good start. If anyone is sitting next to somebody who raised their hand as a relative newbie, you can just raise your hands again if you're pretty new to Python. If you're sitting next to a person like that, help them out, please. If they are running into problems, you're the expert. Okay. I'm Jim Bednar. I'll be presenting this, at least unless my voice gives out. This is my colleague, Jean-Luc Stevens. We're both from Anaconda, which is local. We've seen lots of Anaconda people around here and former Anaconda people who are now starting their own companies and such. It's kind of cool. All right, so the Post-it notes are for your laptop. Please put a green one on there if you have anything running. If you've followed the instructions and you have something running either locally or by clicking on the cloud thing. Everyone should have a unique username and password for the cloud offering, and so you shouldn't be stepping on each other's toes unless I made a typo. But you are all still sharing the same machines. So there are a couple of 40-node clusters that these accounts are on. So if everybody's running something enormous at the same time, it is possible you'll step on each other's toes. Probably not. We're not being very ambitious in this talk, but just be aware it is a shared resource. And of course, Wi-Fi is a shared resource. So if everybody is conda installing an environment at the same time, you might be fighting each other for bandwidth. Okay, so put your red Post-it note up if you're having problems following the instructions. If you're just working hard and haven't finished it, then no Post-it note. Green if you're done. If it works, because I want to see a lot of greens before I get heavily into anything. Okay? If I fail to spot a red one, wave it at me, and I'll send Jean-Luc over to help you out. Okay? All right, so to make good use of the time, I'll start, but I won't be assuming everyone's ready to follow along, so I'll just be showing off some stuff at the start. So don't worry if you're not done setting up. Keep setting up. That's your main goal, to get something running. In fact, that's what I want you to walk out of here today with. Our ambitions are low. We want you to have run something, to have successfully run it. That is the only goal here, really. Well, to be exposed to some other stuff, but to run something yourself. So if you're not able to set it up and it's not working, that's something to work on, and we can help you with that. All right. So this is the basic structure of the talk. Can people see this in the back of the room? It's bright enough? Okay, thank you. So we're in the setup phase right now. Then I'll have a background and demos, kind of show you various examples of things that you will not be able to do during this session. They're more ambitious than that. And then we'll start out with kind of the one-liner, make a dashboard with one line of code, and then you can play around with that for a while. Then we'll say, okay, step back and do it a little more step by step. And then be more ambitious. So it's okay if you get to here and aren't able to do the further exercises, at least you'll have done something. If you're failing at exercise 1, pull somebody in, talk to your neighbor. Hopefully you get something working at least. All right. If you've got something running, you can run this first. Let me restart and clear everything. I suppose I should have asked, how many people have used a Jupyter Notebook? How many people have not used a Jupyter Notebook? Great. We'll fail to explain lots of things then. Okay, so the first cell in this notebook is just to make sure things are installed properly. All it is doing is checking the versions of Panel, Pandas, Matplotlib, Bokeh, and HoloViews. If it succeeds, you'll see nothing. If you see error messages, something went horribly wrong. And it's worth figuring out. All right, so At the beginning, I'll just give you an idea of what the heck panel is. First off, go to the website. Panel is an app and dashboard development system for Python. Now, apps and dashboards, what I mean by that is basically a website, but it's a website that you write in Python. It's a website that you can easily have data and plots and all of your PyData. Basically, everything that's in Python and is data related should be easily able to be turned into a website, to be turned into something that you can share with people and be turned into something interactive in Python. Now, obviously, you could go and write a website in HTML and in JavaScript and CSS. If that's your thing, go for it. Bye. This is for Python, for people who are comfortable in Python and want to stay in Python, but still want their work to have an impact, want to be able to share it to other people who aren't necessarily gung-ho about Python, but you still want to make an impact on those people, or just for your own purposes. You just want to be able to set up something interactive to play with yourself. Maybe I shouldn't have said that way. Anyway. All right, so back to the task at hand. Panel is an open source library developed by Anaconda, and we developed it as part of our services group. The services group has contracts with government agencies and with companies all over the world, and basically we listen to their problems and then we tell them an open source way to solve their problems. And their problems over and over were about how to build a dashboard and how to empower their data scientists to make an impact on the decision makers in the company. And previously, what people told us over and over is, I've got my Jupyter notebook, it looks great. And then I hand it over to the JavaScript team, and 6 months later, they make an app, and it isn't right, and we work, and then eventually it's sort of okay, and meanwhile, the business has moved on. That is not how things are supposed to work. You're supposed to be able to be a data scientist. You discover amazing things, you find cool trends, and you want to explore them, and then you want to share it with people who are going to make a decision. Fund that. Can that project. Do this, whatever. You need to be able to make decisions. So we over and over kept hearing from people who had trouble linking up their cool data scientists to actually justify their salaries by having an impact on the organization. So we listened, we kept hearing this over and over, and then we said, okay, we're going to break down, we're going to build this as an app. And we're going to build some library that makes it easy to connect up something you got working in Jupyter to being something that you can deploy. Now, at the same time we were building this, other people started building other things. Voila, has anyone heard of that? That is a sort of competing tool for some of the things, and I'll kind of point out where it overlaps and where it competes. Voila lets you take a Jupyter notebook and deploy it as well. It doesn't have any special features to make that easy, but it can take a Jupyter notebook and lets you deploy that. Panel can be used together with Voila. But we're going to focus on talking about Panel here because we can completely control that. There's also a package called Dash. Dash is a little different. Dash doesn't take Jupyter notebooks. Dash is for building dashboards in Python, but only if you're building a dashboard. What Panel does is try to say, you're working with a Jupyter notebook, you make something, you add a few widgets, you make it a little bit interactive, and you gradually build up an app. And eventually you build up a dashboard, eventually you build up a multi-page dashboard, eventually it becomes some complicated system, but you never had to switch tools along the way. So Dash is not like that. Dash is, okay, I did some stuff, now I'm going to build a dashboard in Dash, throwing away all of that. Voila is more similar to Panel in that way. You have a notebook and you can deploy it. So Voila and Panel are more similar. All right, so here's just some random examples. These are all taken from the links here, examples.pybiz or the Panel gallery. This is the Panel gallery. I've already opened some. Hopefully they're still running here. Just to clarify, there are two types of deployed Panel apps. One is where there's Python running. So you click on things, you're in a web browser, something gets eventually transferred to a Python server, some computation happens and you see the result. That's a Python-backed app. If you go to the Panel website, some of the things you'll see there are Python-backed. Other ones were written in Python, but the final result has no Python in it. It's just some deployed HTML, JavaScript, and whatever. I think one of these is, okay, here. This one is an example of a deployed app here that is only JavaScript. So this thing was written in Python. This is panel code. You'll get to that. The final result is an app with widgets and so on. It's all connected up. But the result is in JavaScript. Hopefully that doesn't hurt you in any way. Basically, you write a specification. Most of these are declarative. It's declaring what you want. The actual implementation of it is in JavaScript. So most of the things you'll see are different. They require, like this one requires a running Python process. And so if you've not visited the page in a while, as I haven't, I have to reload, and I'll start what's called a session. I'm here in my browser. If I drag something here, it will send a command over to the Python process. Some computation will happen. Things will come back, and it gets updated in the browser. That's a Python-backed system. So this Python-backed system, in this case, is drawing some pretty pictures, basically. This particular one, okay, yeah, this one is deployed on the cloud. There's some AWS server that's burning some money as I do this. My employer pays. So whereas the other one I showed you here, that's all happening inside the browser. So there's some JavaScript code. Eventually, it just gets downloaded in the browser. The computation's happening in the browser. There are pros and cons. If you have a Python server, you can do anything. You can basically any possible computation you can write in Python, you can have something on that page that triggers that, and you get the result. And if you've made it into something that happens only in the browser, then you can easily just email it to people. So there's pros and cons. I'll show you both. Let's see. This is one that was, well, it was running. So this is just something to help you explore a little mathematical thing. It has one widget. You get to choose what your function field is. That one's a boring one. And then you can click around. Whenever you click, something happens in the browser, collects your mouse click, figures out where you are in this plot, sends it to Python. Python computes a function, plots it, goes to the browser. Okay? So this one's Python backed. This one couldn't be done in the browser because this is 213 glaciers in the world. You can select on each one of these things, and all these plots are interlinked. This particular plot is done by a program called Data Shader that turns data into images, and that all happens at the Python side, the server side. The image goes into the browser, so the browser doesn't crash even though there are millions and millions well, in this case only 213, but this could barely probably work in our web browsers, but it can work with millions. This particular one is 1 billion GPS locations here. This couldn't happen in the browser. So if I zoom in here, what's happening is it sent a request to Python, told Python to render it, and now it's going to re-render. You can actually see the delay with Python here, because this is a huge data set. It's just on my laptop. You see what's happening there? So this is the sort of thing that you can only really do with Python and JavaScript, because the browser's model of how to manage memory does not involve 1 billion points. It will never, as far as I know. It involves a very small set of things, sandboxed from every other browser tab. But Python can handle whatever size of data you want. Okay, one thing I have, well, this shows a little bit of, one thing I don't have a good example of, we tend to create a lot of these for our clients and then we can share them, complex multi-page apps. They're harder to share as examples. This particular one is not one that we made for a client, so we can share that, but it's also not very multi-page. It has a few tabs, but you can actually use these tools to create things that are whole websites and have state that persists across multiple pages and such. That's much more complicated, but just so you know, there's headroom. You can build quite complex things, all still in Python. Okay, I think I'm done with demos and ready to move on to actual work. So I do not see any red on anything, so if I see some things without a green post-it, if you have something running of any sort, please put a green post-it on your machine. If you're having problems and have nothing running, please wave a red post-it and make sure we know. Okay, I guess we're ready to get started. Before we do, does anyone have any questions so far? see if you're in the right place or have some basic question. Yes?
I was just curious. So I know you mentioned functionality to export a static snapshot of,
Yeah.
of an app. But if your visualization is like really low intensity and you wanted just to export it, say, to JavaScript
Yep.
and render it on the front end and
Yep.
Just have somebody play around with it,
Yep.
how would you do that?
Well, we'll get to that. There are a lot of options. One of the simplest ways is if you have something that has, let's just put up something here that has a widget. Something that is very general that could work in all cases, but you'll immediately see the limitations is, if no matter what is here, this is a function of these values. Now, what is the, if you had one slider and it had 10 values, you would just need to export to the browser 10 plots to handle one slider. But what if this one has 10 sliders, and this one has 10, and this also has 10, and this, and so on? That space of possible things to export to the browser, while very general, you can handle anything, it'll immediately become a very large thing that you're trying to export to the browser, because you're essentially pre-computing everything you might ever ask for in Python, getting it down to the final JavaScript, HTML, static stuff, and shipping all that to the browser. That is always going to work, but it's in technical terms, but it may eventually, it'll quickly overwhelm your browser. So there are other things you can do which involve figuring out a way to link this using JavaScript to this. You write 2 lines of JavaScript and it connects up directly. And then there are other things where we've already done that for you. For simple things like having something to control a color map, that just has already been solved in JavaScript. So we can do it in Python, but we also threw in a little thing where we did that connecting up directly in JavaScript. So there's a complicated answer. Basically, in Python, you can do anything you want. Some subset of those will immediately map directly to JavaScript and be done. Even if you can't have that, you can do this. Exhaustively collect all the data and do that. That's also automatic. If you want anything more ambitious, you're going to have to do a little work. So basically, if you can count on Python being there, you can avoid all the work. You can just stay in Python, do some Python, get some app, and if you can count on there being Python to deliver it, you're done. Beyond that, you do more work. Yes?
May come this later, but will it be possible to take the resulting dash, how you mentioned it can be paginated?
Yep.
And those pages be turned into a PDF document to be downloaded?
Sure, I guess. The underlying panel works with a ton of underlying libraries, and as long as those underlying libraries have ways to generate SVG, typically, that you then turn into PDF, that can work. You can also just hit print on a particular page in your browser, and that often works. But it's not intended, if you take a step back, the underlying Jupyter notebook is usually easier to turn into a PDF. So behind this thing is a notebook with maybe 12 lines of code. That notebook is much better set up to be able to turn directly into PDF. So typically you'll have a workflow where if you want to have a report, you have a notebook and you spit out a report that's based on that, turn that notebook into a PDF. And then you can also turn that notebook into a live running dashboard. But we haven't typically turned it into a dashboard and then to a PDF because basically this is waiting for a user to do something. Whereas the notebook can lay it out all the choices having been made automatically without a user. And one final point is that all the panel docs that you'll see online, those are all generated from notebooks turned into HTML. And so once those are in your browser, of course, you can save those to PDF there. So that's a notebook to browser to PDF workflow. But good question. Anything else before we start? Okay, let's actually run something. So I cleared my notebook here. If you've already been playing around, you might want to clear your notebook again. Like I said, this is a not very ambitious set of data here. It's not a large data set. It's not a complicated data set. This is meant to get used to give you some success. So this particular data set we're reading, it's appropriate here as it gets a little hot, is measuring the characteristics of a meeting room, the temperature in Celsius, I guess, humidity, how many people, that might also just be whether it's occupied, over a series of time points. So it's basically somebody instrumented a meeting room's climate control, put that out as a standard data set. So it's in a pandas data frame. Panel doesn't care what type of data you have, whether it's a pandas data frame. It cares that it's something that can be visualized, particularly if it can be visualized in a Jupyter notebook. So this particular one, you can see it's got some columns. And now let's say we've figured out a way to plot it. In this particular one, we wrapped it up as a function because we're going to want to call this over and over. But we wrote two functions here. One is, basically the idea is that we're going to smooth, pick one of these columns, smooth the values slightly, and then plot it. And so here we write a function. At the moment it's using matplotlib, but we'll use other plotting libraries, and it's given two sets of data. One is a time series, and one is a subset of that time series that we'll use to highlight it. You'll see in a minute. And also we have a function that will try to compute, given a time series and a smooth time series, find outliers, find things that are very far from the smooth value. What we're doing here actually doesn't matter at all. I'm just trying to explain it. Just think of it as something that makes a plot. Okay, so here we're calling this function. We're looking at the temperature. We've plotted the temperature, so that's the raw temperature, and then smoothed it with a running average window of size 20 data points. And we're going to highlight all the data points that are, I guess, 10 sigmas away from the smooth mean. And so what that does is, here this is, it's basically highlighting areas of sharp change. And if we want to mess around with that, we can change that. How far away do you have to be highlighted? If you have some distribution, you don't have to be 10 sigmas away, you only have to be 5. You'll get more data points highlighted, right? And eventually you highlight everything. Okay, you can keep doing this. If you're a Jupyter programmer, a Python programmer, you can have a function like this. You can explore this parameter space. You can do that already. You don't need panel. But it's awkward and painful. I mean, with two, you have to keep, you don't know what the possible allowed values of sigma are. You don't know what the allowed values of window are. You just type it and you study the code and so on. So it takes some Python knowledge to work with that, even for this totally trivial function. Plus, if we wanted to share this with our boss and we wanted the boss to understand, oh, okay, this is the parameter they need to watch for, this is what we're trying to optimize for, they're not going to be happy with this. So we're trying to immediately get you to be successful, so we give you a one-liner. This is, I mentioned Voila. Voila can use IPyWidgets. IPyWidgets has a function called interact. You can do the same thing we're showing here, roughly the same syntax to use with IPyWidgets and Voila. So up to this point, you can use whatever library you feel like.
But this isn't IPyWidgets.
This is not. No, this is panel. Panel is PN, so panel.interact. It's just copying the IPyWidgets API. So now if we do this, now we have this function. And you'll notice that we have immediately got two widgets. And if we drag the widgets, we can see what the effect of sigma is. And we can see what the effect of the rolling window is with essentially zero work.
So it automatically got those two because of the arguments it passed.
Yeah, so let's see how that works. So this is the magic function. So how does the magic work? The magic won't always work. So we got to understand the magic. Okay, so what's the magic? This find outliers function. That's what we're calling with interact, and it has 1, 2, 3, 4 arguments. Why didn't we get 4 widgets? Because the magic only goes so far. Look at the widgets we got. We got one for window and one for sigma. What other widgets do we need? Oh, well, there's a variable which selects a column in the data set. Interact doesn't have any idea what the column's in your data set. It doesn't know that there is a data set. It has no way to know if the value defaults to temperature, that it could be anything else. those could be any ASCII string, right? Or Unicode. And what about this one, viewFun? Well, that takes this function here. How does it know what possible functions you could get? It doesn't. So what Interact does is to make it be useful, it does what it can. It's like, hey, I'll deal with it. I ignore the things I don't know about. I'll give you widgets for the things I know about. I cannot help you with those other widgets.
So it made that it's based on the fact that the keyword arguments were integer values.
It looks at the default values, that's correct. So if I had changed that to a float, then it would be a floating slider.
Right.
Yes?
How does it determine the min and max?
Very good question. What about this window function? So this is a window. It's going to need to be a window. Can a window be negative? It cannot be negative. Can this widget be negative? It sure can. It doesn't know window. It doesn't understand that window has any physical meaning. It just came up with a widget for you. It doesn't know. It's magic, but the magic only goes so far. So
presumably there's other options you can put into too.
exactly. So you can, we'll get to that in just a second. So basically, the magic gets you one step. And then if that's all you needed, you're done. You go on with your life, you've had success. Great. Took you 1 second to try it out. And it's trying to design to fail gracefully so that the things it doesn't know about it just doesn't do. The things that it does wrong, well, if you don't want it to be negative, don't drag it that way. Okay? So it does what it can. It's a really helpful kind of stupid friend. All right, so what if we break this down, though? We can actually do a lot more with this when the magic isn't enough. Like, what if we didn't want our widgets to be above it? What if we wanted them to be to the right? What if we only wanted one of these widgets? We didn't want one for Sigma. My boss doesn't know Sigma. That sounds Greek. Oh, no. So we want to hide that. Okay, well, now we can look into what the magic is actually doing. And we can help put the right values for the window. So we'll get to that. So first, we'll address David's question, which is, well, let me just go ahead and show that it works first. Whoops, lowercase. Okay, first you'll see, first let's see what we've got, and then let's see how we got it. What we got now is two things. We got window to start at 1, physically realizable. A window can be 1 or higher. Okay, so how do we get that? Well, we got that by passing in an extra keyword argument to the interact function saying the range of window. Okay? So we used our human knowledge of understanding of windowing, and we're able to express that for the interact function. Okay, your magic is not enough. Here's a little hint. So we gave it 1 hint. Okay, what else did we get here? We also got this cool drop-down that allows us to select the different columns in the data set. How do we get that? Look back at the code. We again gave a keyword argument, and we told it the possible values of variable. We gave it a list of the columns in the data set. See that? Now it doesn't have to do magic. It knows what variable can be, and it lets you choose those. Okay? So you're helping the magic along. And the other thing that's happening here is that we can actually, we also told Sigma to be in a more reasonable range. I don't remember what it was before. Oh, it could have also been negative. So Sigma can't be negative. So we told it that. All right, so we helped out the magic a little bit. We also printed this object. So if we call interact, we get the result displays automatically. So if we just do this, sorry. If we just call it, it displays automatically. But what if we try to grab a handle on it and print what we've got instead? Then we can see what was returned from interact is not a monolithic thing. It is actually a compositional thing. It is a column composed of a column and a row. Okay, if you go look back at the original, you can see it is a column. And in this one, this bit is a column. This one is a row with 1 item in it. So, okay, and then what's in there? What's in the column? A selection widget, an integer slider, and an integer slider. And what's in the other one? A matplotlib plot. Okay, so this, now that we've got those, we realize that this magic bundle that just dropped on us, it's not a dead end. We can actually work with that. So let's work with it. Let's take it, reorganize it, everything. So now I said, oh, the widgets were up here. I don't want them to be up here. I'll put them on the right. I'll put a label. I'll tell my boss what to do. How did I do that? I took the original structure here and I indexed into it. I'm going to now make a panel row that consists of item 1, 0, which is the plot. Item 1, 0. So this is just list accessors. So we're using list accessors to access this. This is a list of lists, or a list of it can be a list of lists of lists of lists, however many you want. So you just access something in this composite data structure, and then make a column over here consisting of some text, which is actually in Markdown. That's how we got the bold. It assumes by default text is Markdown. And then we put one widget and another widget, and we ignore the Sigma widget. See how that works? And using this technique, we call this approach shortcuts, not dead ends. We give you a quick shortcut, interact. But it is not a dead end. It is a shortcut. It gets you this way. And if you want to go over here, you just do a little bit more work. As opposed to a dead end, which is, here's the magic. You don't like the magic? Go install Tableau. So that's not going to work. So we don't want that answer. All right, so where are we? All right, so we were able to come up with this non-dead end thing where we could make our own thing. Also, you can see that if you really want to care about the details, if you still want to mess with the Sigma, there's nothing special about it being shown together. These things are reactive objects that if you display a widget anywhere, will still update it. And it also is it's available for you in Python as well. If you want to mess with it yourself, it will update. Maybe you see how the plot is updating, even though I'm just fiddling with this. Oh, you can watch the widget if you're not blinking. If you do this, you'll see the widget value change. Right? So basically, this composite object you got is totally not a dead end because you can pull it out, you can put things around, you can mess with it in Python, you can set up a callback function that messes with it. You can do whatever you want. So you've been, by magic, given this bundle that is probably often useful, and it's not a dead end. You can do what you like. All right. So now it's time for you to play. So exercise 1 is pretty free form, and they get more free form after that. Exercise 1 is to do something. Write some function that does something. If you're having trouble with matplotlib or making plots, just make it return a number. Make it return some text, whatever. You can panel, if you just write pn.panel and give it something like 45, it'll whatever it is, it'll display the thing. And if it's a matplotlib plot, it'll display a plot. If it's a bokeh plot, it'll display the plot. If it's a SVG or a PNG or a JPEG, it'll display that thing. So get something you might want to display. Like figure out, think of anything. If you want some inspiration, click on this link. You can see lots of things like equations or PNGs or different plotting libraries, YouTube videos, I don't know, whatever you want. You can, at the moment, stick to the panes section. We'll get to widgets in exercise 2. So the goal is to get something that displays on its own, and then to write a function that has some arguments and does something. So let's just do some live coding of the sort that you might want to do. Return arg times 2. Okay, and then try this. So what happens if you do pn arg equals 1? Okay, so here's a panel I just created. See how exciting it is? It's got a widget, I drag it, something changes. You do that too. Make your function return strings or numbers or something, write some function with some number of arguments, and then use interact to make it an app. Okay? And call one of us over to help you, wave your red flag or whatever if you totally have no idea what you're doing, or you've hit a roadblock and you really want to find out the answer. Yes?
So it's intelligent enough to understand the type of the argument here, or only after when it is trying to compute r multiplied by 2, then it deduces that the argument is an integer. Or even before that, it understands that it's an integer.
In this case, it's realized that arg is an integer by inspecting the default value and creates an integer slider because it's a default value. It realizes that the thing it's returning is a string because it returned a string. And so it called it once with the default arguments, found that it returned a string, and that's what's displayed. It should be able to return if should be okay even if it's changing type all the time, but we should try that. Yeah. So it doesn't have to, it just displays whatever comes back from that, whether it's an integer as it is in this case or it's a string in these other cases. That make sense? So essentially you've just got a function, and you need to make sure the function has a default value, or panel can't figure out what the allowed values are. And it needs to return something that could be displayed, whether that's a string, an integer, or an image, or whatever. That's the only requirement here. And so basically, try to get something to work. If it doesn't work, talk to your neighbors or call us over. If it does work, then think about it. Am I done? Is this function going to work? Like, what if every time I drag that slider, it takes 10 minutes? What am I going to do then? So try to understand the limitations of what you did, because that leads to everything else. Or the thing you got here, what if I need to click on that and change the font a bit? How can I do that? I mean, try to come up with something that is not solved as well as whatever you've solved. Try to figure out a need, because that's where we're going after this. And I'm checking time now. Looking good. So I'll give you 4 minutes, and then I'll ask to see how far along people are. You can keep working at that point if a lot of people are still heavily into it. Yeah, question? I'm Jay Bednar at GitHub, if anybody is wondering. So you were trying to read my badge. So Jay Bednar.
Question.
Yes.
Any support for memoization
memoize. In many cases, we haven't published a generic interface for that. We would love a contribution for that, akin to what's in Streamlit. I should have mentioned Streamlit as a new competitor. There's Streamlit, Voila, and Panel are basically and Dash. Those are the 4 current hot libraries for dashboarding. Streamlit takes a different approach, which is to memoize essentially everything all the time, because it reruns your entire code every time you drag a widget. So if you're going to do that, you better be memoizing some things to cache them. Whereas Panel allows every widget to be tied to specific independent computation. And so it doesn't come up as often, but it can be useful, and we support it in some cases. Stream, L-I-T. Streamlit lets you use your own browser. Streamlit's for people who don't like notebooks, because it lets you use your own browser, your own editor, your own full IDE, and have all syntax highlighting and everything, refactoring, whatever is in your editor. And every time you hit save, Streamlit will reevaluate that file, having cached results along the way, and update what's on the screen. So Streamlit helps you work with an independent file. The caching helps there, and it also lets you write something that where as you drag widgets, it's cached. But Streamlit focuses on the low end of what you can do. It makes it super easy to put some widgets and put something on there, and then it hasn't been around very long, and it kind of has a dead end. Like, oh wow, that looked cool, that was great. What if I want? No. So it has a really strong case for a certain type of usage. And a few years from now, it may expand to handle the types of things that Panel can do. But Panel was built on Bokeh, which has been in development for since 2012, I guess. It is a mature and established library. Panel is new. Panel is sort of easy to use features on top of, and support for other libraries that Bokeh didn't have. Panel is saying, okay, building on what's in Bokeh, which is rock solid, been there a long time, and really covers all sorts of complicated situations that people haven't even thought of yet. On that basis, can we build something that's much easier for a data scientist to use, something that works well in Jupyter Notebooks, something that makes it easy to make apps right away? So that's what Panel is. So it's built on this deep and wide foundation. Streamlit there's no deep and wide foundation. It is exactly what it is today. And it could have a great future. So it's fun this is a really good time to be trying to do dashboarding in Python, because we've got 4 power players all watching the blog posts from each other and say, hey, I could do that. And battling in the blog posts. Yes?
Specifying the min and max. How do I say that this variable is dependent on another one?
Ooh, you wait till the next section. Good question. Okay, is anybody so deep that they can't bear to be pulled out of it? Okay, and so show of hands, how many people successfully did anything? All right, excellent. That's actually, you can go home. I mean, anything else is a bonus. As I said, my ambitions are low. If you want to have high ambitions, there's a YouTube video of me at SciPy this summer, 3 hours long, being much more ambitious. If you can handle listening to me for 3 hours, you go from 0 to very complicated big data, geographic applications, whatever. But that is much, that takes your head, getting your head around, and takes kind of buying our entire stack. Panel's one of the things we work on. We work on a whole bunch of things, and that whole group is called HoloViz. Panel's one of the products there, but it's the one that reaches the most people. I say products, this is all open source. We don't make any non-open source. All right, so we're going from there. That was exercise 1. You did something. How many people saw a limitation, like something like, one was just pointed out there. What if I want my widgets to depend on each other? Like if this one might be a maximum value for this other widget. That's a limitation. I'll tell you how to address that. Anyone else see a limitation, or like, it looks like it can work, but what about this? Anything like that? Yes?
I had a kind of a weird thing. John just
just helped me. I was doing too much sort of matplotlib inside of a function.
Yeah.
And so it wasn't updating correctly unless I had my function return the figure object.
That's right. So matplotlib and Jupyter Notebooks have a long and messed up history of how it interacts with the notebook, how it displays things. The typical thing in matplotlib is to use matplotlib inline, and then your figure doesn't get returned. Like normally, if you take something at a Python prompt and just write 7 is returned and it's displayed, and you put a string there, the string is displayed. But if you do a matplotlib figure inline, what's returned is some kind of garbled, meaningless text, and then it also displays your plot. Panel requires whatever you do, it has to be returned, because otherwise Panel can't get a hold of it. You might see it on the screen, but Panel can't get at it. So you have to make sure that so the code up here for matplotlib is specifically making sure that it returns a figure, not just displays a figure. And that's what makes everything else work. So you need a function that returns something that is displayable, and then interact will work. That is your one requirement. And matplotlib and Jupyter could have been written to do that way. The Jupyter interface to matplotlib 10 years ago could have been written that way. It was not. It was written to display it as a side effect, inline. I don't know who wrote it. I don't want to meet this person. It is weird. But it can be made to behave quite reasonably. There's nothing wrong with matplotlib. It's just about the default interaction when you use inline in the notebook. So don't do that. Do this.
So I have one other question.
Yes.
Because actually, so I noticed in your find outliers, the data frame called data is used as a global variable.
Correct.
Within. Now, if I wanted to avoid doing that and passing it as an argument, just to make it, slightly more robust,
Yeah.
would that confuse Panel?
It wouldn't confuse Panel. It might confuse interact, in which case you would need to give interact a hint just like you do for displaying the ranges. You can also do a hint that tells it, don't try to plot that thing. It will almost, in normal cases, it will ignore the things it doesn't understand. If it finds something and you realize, oh, it's paying attention to that variable, I really want to ignore it, you can pass a little hint. It has never come up for me, so I don't remember the syntax. But there is code to do that. And that's the same for interact in IPyWidgets. It's got all sorts of ways to give it hints. Okay, any other limitations or problems that you're anticipating? I'm going to focus on a huge class of limitations, which is essentially what happens when I drag this slider. What happens when I drag it is it calls find outliers, and it generates something and displays it. Well, what if that function takes more than a second? If it takes 5 seconds, as I drag this, it can easily start to lag behind what I want. If it takes 5 minutes, you better not drag that thing. You might want to click like that, and then we'll come back. You see that? Now, that doesn't mean you can use it. You can't use it for functions that take 5 minutes. You totally can. But if you use interact, you're going to have a not very usable display because any change to anything will result in the entire set of computation being redone. So interact is a great way to get started if your needs are modest. But if you want to do something complex, like have these interact in some way, as was mentioned, you can't use interact. And if you can't accept that this one function is going to be called every time you do anything in the GUI, then you're going to have to do something more complex. Just as an example, the more complex one, I don't know if this is still running here, yeah. So this is a more complex one, and what's happening here is to regenerate this whole data would require iterating through 1 billion points. Yet here, I'm dragging this slider, and it's immediately updating this kind of cool mountain range thing. How is that working? And I can turn off the data as well. That's all immediate. The reason that's working is that this is actually a pipeline of operations, and these sliders only affect the very last step. The data doesn't have to be re-rendered for me to change its opacity. That is happening at the very last step in the browser. And I can actually change the underlying plot underneath that. That also doesn't require rendering the data, because this is an overlay of data on top of a map. I change the map, I don't have to revisit the data. So each one of these things, I can change the color map of something immediately. It doesn't have to regenerate the data. But if I wanted to change what I'm computing, that's going to regenerate the data. And probably you can't see because I chose a weird color map. But in fact, it's still computing. It's going to take a while. It won't take 5 minutes, but that one is going back to the original data and reaggregating everything. And so this is a panel app where each one of these things has been very specifically tied to the computation that it needs, so that you can get the fast things fast. The slow things are slow because they're slow, but you don't have to get the slow things if you don't need to. Okay?
Can you provide that as like a hint to users so they're aware that some things will take longer than others, like maybe annotate it?
You can do whatever you want. This is a column of widgets. It can be a column of widgets with text. One thing I don't think, maybe Jean-Luc can correct me on this, I don't think we've ever implemented the hover text for each one of these. It is supposed to be there. We already have ways to declare it, but Bokeh didn't make it easy to make the hover appear. But you should be able to, every time you have some variable, have associated text that hovers. If that doesn't work right now, then we just have to make the right person listen to us. Yes?
If your function errors out, how can you display that?
Display the error?
Yeah.
The error will often go off into La La Land, depending on how you created this. If you made it in a Jupyter Notebook, this particular one is in a Jupyter Notebook that was saved to disk, and then it was deployed at a command line. And so on that command line, there will be messages printed, and also there are messages printed here in the JavaScript console. In this case, there are no errors, so I'm happy. But if you look at your browser's JavaScript console, some errors will go there if they're generated at the JavaScript side. So if I were doing something here and there was some coding error and it realized that some variable is undefined, that will show up in your browser's JavaScript console. It depends on your browser how to get to that. This particular one, it's under More Tools, Developer Tools for Chrome. But each browser has its own way to get to the JavaScript console. So, yes?
So when you are trying to manipulate one of those high-intensity functions, like let's say it's an aggregation function, which you
Yep.
change, right? So you're saying that it will trigger a Python function in the backend, and that will run this,
Pipeline.
this big pipeline, which is very intense.
It'll,
And the result will be stored there, and how it will be rendered. Will all the data points come into your browser, or it will result in some tabular form somewhere away from the browser, and only the distilled information will get to the.
So we're veering outside of panel for this question, but it's a good question. Panel is happily displaying stuff, but what it's displaying can be arbitrarily complex. And in this particular app, which I'm reloading and it's waiting on, but for this particular app, it's using a program called Data Shader. Data Shader it takes data sets of various types, renders them as a fixed-sized array, and that array is only what's sent into the browser. So the way that we can have a billion data points here that we had earlier was a billion data points are in Python's memory, or even not. It can work out of core using Dask. The data points can be on your disk. It aggregates them, renders them into something, a fixed-size array. That something gets put into a binary chunk of data. That binary chunk of data is sent to JavaScript in the browser. The JavaScript in the browser scales and puts that on the screen, and then you see it update. So at no point is the data ever in your browser with this program.
Some kind of a rasterizer.
It is a rasterizer. So it's a handy one because it lets you be independent of the capabilities of your browser and Python.
So you're saying the results could be stored anywhere, maybe in a Redis or some high, high capacity cache, and you can have the browser read from the cache?
You can do that, but right now it's just using the default, which is that when you interact with this plot to drag it around or whatever, Bokeh realizes that the range that needs to be plotted has changed. Bokeh asks Python, okay, I'm out of date, give me the new stuff. It waits, you still see the old stuff, you saw it earlier, and it waits, it has the new stuff, okay, got it, put it on here. So the data is actually not stored anywhere, it's just requested by the browser. The browser's in charge. You, the user, are in charge. You issue a request. If Python's not there to satisfy it, nothing ever happens. For instance, on our website, if you just go to datashader.org and try out some of the plots, they might or might not actually do anything. You go and zoom in on this thing. Well, it's just in the browser. It doesn't update because there's no Python. This is just a website. It's just sitting there with a static export of my file. JavaScript is happy. It does the stuff. It computes the new range. It says, Python, give it to me, and no one ever answers. It's very sad, actually. But that's how the website can work. So the Datashader website has no Python backing unless you click at this very top. Then you can get a running version of it. When you click on that, a Python process is launched, there's a Python process sitting there. A session is launched on that process. So this is what you see in a static export of something that uses Datashader, is that nothing Pythonic ever happens. Okay? Anyway, that's Datashader. Another in our family of tools, and it's using a program called HoloViews to do it, another in our family of tools. I'm here to talk about Panel. So, back to Panel. All right, where were we? We're finished exercise 1. Okay, we ran up against a limitation of interact is my conceit, that we played around with interact, and whether you did or did not, just imagine at some point you hit a wall. You can't force things into interact. You added some hints, you added some more hints, but you want to do something that doesn't really fit with interact. Fine, you can drop down a level and then work with widgets directly. So if you do that, you can do the same stuff you did before, but here, instead of using the magic of interact, we explicitly say, I want a widget. In fact, I want 2 widgets. First, you create a couple of widgets. Here, one of them's an int slider, just like you saw before. But in this case, I didn't want that drop-down menu. I wanted one with these things. You can actually give that as a hint to the interact, but let's pretend you couldn't. Let's explicitly make a widget like that. Now, if we did that, and we just look at that one widget. Okay, I've got a widget. It doesn't do anything, but I've got a widget. And the same for this other widget. So you can just make all the widgets you want. They won't do anything until you do something with them. So this is just a way to explicitly start making widgets. So let's say we made a couple of widgets. All right? And then having made a couple of widgets, and you can see at the Panel website all the widgets that are available. There are lots of options. All have been originally published by Bokeh. So let's say we made some widgets. Now how do we get to where we were before with interact? It's actually quite like what we were doing before. What we do, but here instead of saying, I'm going to magically inspect this function and make this blob, here we made some widgets, and you're going to decorate the function and connect up the widgets to the function. How many people know what a Python decorator is? How many people do not? Okay. A Python decorator, for the people who do not, the typical thing you use it for is to take a function and transform it into another function. So you've got some function, you decorate it. That little @ symbol means to decorate that function. So this line doesn't do anything on its own. That line applies to this one. And it transforms this function that takes a string and an integer, and it transforms it into something that can take widgets. That's what this does. It expresses a dependency between some arguments and some widgets. Make sense? So here we're declaring that this argument, which is a string, actually should be hooked up to this widget, which is this button, this radio button widget that allows you to select between various strings. Okay? And the same thing for the other one. We say this window argument is actually, they're the same text, but here this is an argument. Here that's referring to this thing in the global namespace, which is this int slider. So we're connecting this radio button and this int slider to this text and this integer argument. So this function here doesn't know anything about widgets, but we've transformed it into a function that does know about widgets. And in particular, it knows about these widgets, and it connects those widgets to these. So it lets you write your Python, make some widgets, and then connect them up. Okay? And so now when you do that, your widgets work. You can select everything. You can put it together in columns and rows just like you did before. This is the same thing that you got out of here. It's still a panel if you print it. It's a blob. It's not just a blob, though. It's a compositional thing. One of them is a function, one of them is a column. In the column is some markdown and a couple of sliders. That's what we are seeing. Okay? So we've just gotten rid of all the magic, most of the magic. Instead of the magic of interact, we're explicitly thinking about what widgets we might want. We're explicitly instantiating them, and we're explicitly connecting them up to the function. Okay? Hopefully you can see that we're not relying on magic as much anymore. You make all the decisions about which widget you might want and not want, about what their ranges are. Here the ranges are declared when you declared the widget. It starts at 1 and goes to 60. You told it that. You can tell it whatever you want. It doesn't discover it. It's no magic. It does its thing because you told it to. Okay, so this is a very explicit way. But it's not much more code, really. It just requires you to think about widgets and functions differently than the interact one. The interact one said, damn it, make this thing interactive. This is taking a step back. All right, I'm on a project now. I'm going to make some widgets. I'm going to connect them up. It's a slightly different task, but the result can be very similar.
Would you have been able to do the radio button with interact?
Yes, you have to pass a hint that tells you the type of widget you want. I never do that, so I don't know the syntax, but it's in there somewhere. The interact function takes tons and tons of hints. So if you want to deeply double down on interact and only use interact, there's probably a way to force it to do the things you want in very many cases. Me, I say, oh, I hit some wall. I said, no. I'm just going to make it myself. Whatever you want. Okay, exercise 2. Do the same thing you did before, but now start with some widgets. Whatever the heck widgets you want. And then connect them up using this depends decorator with some function that displays something viewable. You already had a function that displayed something viewable. Just copy it, put some widgets in front of it, and add this little depends thing. So it'll be something like this. You make some widget, you make a function, that function has a dependency declaration, and then you lay it out as a panel row or column or some combination of that. Okay? All right, have fun. Oh, by the way, how many people are running locally on your own laptops? How many people are in the cloud? Half an hour? Cool. Glad it's working out both ways. The local one you can take with you. The cloud ones we'll turn off tonight. So, because we're paying for that. Yes. Yes, I'm just checking to make sure we're not over time. We got plenty of time. Okay, great.
The picture above, right? Can you state it again? Like how did you have the plot on the left side and the columns on the right side?
Right here. So we can do whatever we want. We can have.
How do you specify that?
Right here. It's a row of this plot and some widgets. So if we want the widgets on the left or both places, we put them on both places. It's a row of widgets, plot, and more widgets. And if we don't want that, we can have a pn.column. Yeah, now we can do a plot with the widgets, and then a column that has a plot and some widgets. It's obviously bad design, but do what you like. And this is not the only way. You can do row and column. Panel has other things you can do. You can say divide up your whole screen into grids and put something on this grid cell and this grid cell. There are lots of options. This is one of them. We try not to overwhelm.
So there's not a way, is there a way to do like a...
There's a responsive mode.
Well, is there a way to get the sizing? Because like in the room occupancy...
Correct, yeah, it doesn't know how wide this widget is going to be when it's doing that. Yeah, there you do, in this case, you do pn.panel. Pn.panel is a function that turns whatever the heck you give it into something the panel can deal with it. And so if I do that, it won't have done anything at all. But it gives me a way to now pass an argument to this, which is width equals, which isn't working for whatever, oh, because maybe the row also needs it. I don't know. But basically, you should be able to pass arguments to whichever one needs to be controlled. Whatever the reason, that is not achieving my goal there. But yes, you should be able to, anything that can be displayed is displayed by calling this function on it. This function can take arguments. What that function does is like pn.panel 5. If you see what that is, it's a string. So I can instead do pn.pane.str5. And it's the same thing. So basically, panel delegates to some pane class. If you go to the panel website, you'll see a whole bunch of possible panes. Panel tries to detect what is this thing and allow you to pass arguments to it. If you want to have more control, you figure out what that thing is, then you can find out, you can do the help on pn.pane and see what arguments it has. And so it has a good number of arguments. And then you can mess with those. Okay? Yes?
If you knew that your function was going to take like 5 seconds, could you rate limit the number of?
You can throttle. I don't know a way to throttle at the panel level. When we do throttling, we do it at the underlying plotting library. That is a good question. The author of panel happens to live in Berlin, so he's not here today. He was here actually a couple weeks ago. He can answer that for you. That's Philip Rudiger. And if you go to panel, it'll have a link to our Gitter site. You can chat with us. We're also setting up a discourse site. That sort of question is well addressed there. Because yes, as you set up complicated apps with, you'll want progress bars to appear in the right spots. You'll want throttling. Panel does have progress bars. Throttling is an answer I don't know. It was great.
So, apologies if you already brought this up or pointed to what should look.
Yeah.
Figure this out, but let's say you create a nice visual interactive and shows what you want, but then you want to embed it on a, make it not look like a supernova. Basically, at that point, what would be?
That we have not covered that, but I will answer that pretty quickly. If you have something that's working for you in a Jupyter Notebook, you do .show, and it'll launch a web server on that particular port. This particular is a very unambitious dashboard, but it works. Anything that you can display, basically anything that is the result of pn.panel or pn.row or .column, pretty much anything you can display, just add .show to it. And that's mainly for debugging because it means that you still have your Jupyter Notebook running, but you've also launched this separate thing. And then we'll get to what you want to do when it's not debugging. When it's not debugging, what you do is go to your command line, and if you actually want to launch it separately, you will do so. I'll make the text a little bigger, but it's too small for me to read to do that. There we go. Okay, so what I did was take a backup copy of the talk that I was showing and then run a command called panel serve on that. And what that did is run through all the cells in this notebook. It's a backup copy because I've been messing with the one I was showing you. Who knows what's in there by now? But this backup copy is what I started with. Oops, no, actually I ran the original instead of the backup. I should stop that. Okay, so I run this command called panel serve and gave it my notebook. And what it's going to do there is go through every cell in the notebook and execute it. And if it finds something that can be served as a dashboard, and I'll show you what that means, it will serve that as a dashboard. So it launched something at this URL. I could have run this on an AWS server, and it would make a fully public thing. This is just running on my laptop, so it's not public. But okay, so it launched this thing. Now, what is this thing? You actually have to look back in the notebook for something, a little trick. Somewhere in my notebook, I put a little hint. I took some panel object and I said .servable. That does nothing in the notebook, but what it does is if you save your notebook and you write panel serve, everything that's been marked servable will now be launched as a dashboard. So this is how, when I'm showing you these things, any of these apps, behind this app is a notebook. A notebook was saved to disk on a cloud server somewhere in DigitalOcean. There's a command was run, panel serve, the name of the notebook. This thing in the notebook was marked servable, and that's what got served. So it allows you to easily transition between a notebook, fiddling around, debugging a standalone server, deploying a standalone server, and leave it running forever. These things are running at examples.pybiz.com. They're just running forever until when they go down, they restart. And so these are public deployed things. If you visit them and you start messing with it, something happens in Python and it starts consuming memory, somebody else visits it, eventually the machine's going to go down. There's a Python server behind it with real computation and real data and real actual work to do. It's kind of unlike a typical website, which just bumps it all down. All it has to do is deliver some bits to your browser. Here, when you hit something, things happen on a server. Costs are incurred. And so that's both good and bad. I mean, it's bad because if you wanted to be Bank of America and have a website, this is not a good way to do it. Because 1 million people visit it, it crashes immediately. But if you're a data scientist and you want to get your work out there and you want to leave your work in Python, this is a great way to do it. So that's who our audience is supposed to be. All right, so this is the section called deploying panels. If you do this on your own laptop, this will work. Like it will launch this thing. If you do this on the cloud server, I actually haven't tried it. I don't think it's going to do anything because your cloud notebook is totally firewalled in something that only shows one port, and that's the one that has a notebook on it. This is going to launch on some other port. It succeeds. It's running there waiting for someone to contact it, but all the contact to it is being blocked and firewalled. So you can run it, but unless you're on your local system where you have the authority to start a web server and that is not going to be firewalled, then it won't do anything useful. So this is the section of exploring further called deploying panels. We just did it a little bit earlier. And just so you know, this is a little trick that's useful in a notebook that lets you use the same notebook for a notebook and for a deployment. Panel doesn't know anything about anything. When you call panel serve on it, it may as well have been a .python file, .py. Panel doesn't require notebooks, doesn't need to know about Jupyter. There are separate things that make it work well in Jupyter, but panel doesn't depend on Jupyter. So you just write a straight panel, take this thing, paste it into a Python file, use panel serve on that. So you're fully independent of Jupyter. If you have security concerns about deploying Jupyter, there's no Jupyter. Okay? The Jupyter's there for you to play around with, not for the deployment. Yes?
In that line, in that statement, occupancy.servable. Occupancy is the object that needs to be displayed.
Yeah, occupancy was up here somewhere. We made, it's up here.
Okay, and string which you pass as an argument in double quotes.
That's just the name of it. You can put it, you don't have to put that, but it gives you a name to the deployment. You can see it right here. If you can read that, that string is showing up right there. It's just the title of the web page. When you serve it, what should you serve it as? In this case, you should serve it as something that is occupancy. So that string shows up there. If you leave it off, it'll show up as bokeh or bokeh server or something. So if I always put the string because if I launch 6 things, then they all have the same name. But otherwise, they're not important. Okay, so that's so we skipped ahead to deploying. We have one more section here. We have a little bit of time, and this part I'm not expecting people to succeed at. This is everything up to now. You've been able to use whatever plotting library you want. I don't know how many people actually try to plot in any library. That's what I figured. A few, but you could totally do it. You just have to set it up and put the data there and so on. That's fine. At this point, and it would have been the same for any plotting library, because all it is doing is calling a Python function and dumping out the results. Anything that can dump out an HTML or SVG or PNG, it can work with it. At this point, let's get to the ones where you have committed to a particular library. Let's say you're working with Plotly or you're working with Bokeh. These two are libraries that give you interactive plots, not just static dump of something. At that point is when you get to do really cool stuff. But you have to commit to a library. So everything else is general, will work for anything. At this point onward, we've picked a library. We've chosen to use a wrapper around Bokeh called hvplot. hvplot, just a quick way to think about it is, if you can do pandas.plot, you can do pandas.hvplot. Pandas.plot gives you a PNG. Pandas.hvplot gives you an interactive full Bokeh figure. So let's say we've committed to that. You can do it with Plotly. There's nothing special. It just has to be, we're going to do things where you now have an interactive plot, where you can drag things around and you can, you'll be able to tie specific actions to events that happens in these plots and so on. So in this case, what did we do? We just wrote this one-liner, actually hvplot replaces the matplotlib plot that was like 7 or 8 lines. This is just, give me a simple bokeh-based hvplot. And this hvplot supports this syntax where you can take 2 plots and overlay them. That's overlaying this background plot with these outlier dots. So that's all this is doing. It's just given this data and this data, where the second one is a subset of the first, plot the first one, and then plot the second one, not as the default of a line, but as scatter plots that are orange. Okay, so we just wrote another function here, and we passed that function into our previous find outliers function. So we didn't need to write a different find outliers function. We just wrote a different plotting function. So if we do that, we can do just the same thing we did before. We get a column and a row and some panel, and oh, here's where I'm using that trick. I could have just put that text, but here I wanted to make the text wide and not say hello to my mother, and be able to put a parameter on that text. So, okay. And then make a little app here. This is actually less work than the original matplotlib. It is not dumping out an image like that was. This is dumping out a bundle of JavaScript. And it's great. You work with it. If you look at the code for this, it's like, ooh, somebody did a lot of work on some JavaScript. I didn't do that work. I wrote that. And so it's relying on more JavaScript magic, but otherwise it's the same as before. Yes?
So another embedding question. So with Bokeh, you can embed it either standalone document or something that's backed by a server, right?
Right.
So is that also an option?
Yes.
Not just like there's always a server, but
There's not always a server. So if you go to the, like I showed on the datashader, maybe you weren't here yet, on the datashader website, if you go to our various websites, you'll immediately see HTML, JavaScript, or whatever. Sometimes there's Python behind them, sometimes they're not. And if there's Python behind it, amazing things will happen. If they're not, you do things and you think, oh, that should have an effect, and it doesn't. That's basically. So there's some class of things that'll be exported statically, and you can do more work to make that class larger. But you need the Python backing if you want access to everything. And so, okay, so here's what we did. This is just showing off hvplot. This is just getting us in the door. It gives you an interactive thing. What we really want to do is do deeply more complicated things like this in this case. So here we've tied the hover we figured out what our X position is in the hover, and we've used that to update this table over here. This is the sort of things you're going to get to, but you have to commit not just to panel, but to a particular plotting library and how to connect up things in that plotting library. So that's not about panel. It's about whatever you're showing. Panel did not make the connection between this and here. You made the connection. You're just displaying the things. Make sense? So you have to learn whatever library you want to use, the tools it has available for doing that. We're using HVPlots tools. You use whatever you like. But here, just to give you a flavor for it, what we did is create, HVPlot is built on HoloViews. HoloViews has this idea of streams. This particular one is a stream that listens to the X position of a pointer. So that stream all by itself, when it's given a source, in this case this line plot, all it will do is, when the pointer's in that plot, it reports back the X position of that pointer. It's up to you to do something with it. What it's doing here is updating this table. We were set up, you notice this depends. Now we're depending on this stream. Instead of depending on a widget is a way to get a stream of values from a user. A stream is a way to get a stream of values from anything. And in this case, the stream of values comes from, not from a user doing a widget, but a user hovering. HoloViews doesn't care, it just accepts streams of all sorts of types. So it can accept streaming data, user events, periodic events, whatever. In this case, so we're creating a tap stream. Really, it's not tap, that's just Bokeh's term, but it's just showing you where your pointer is, so you could tap. And it's connecting it up to the table. So what it does here is, in this function, it connects it to this line, and it says, that's the plot I'm watching. In this function, we're saying, here's a function that's watching you. Here's a function that's watching that. And so that's what makes this table over here depend on what's happening in this plot over here. None of this has to do with panel, per se. Actually, this depends on an underlying library called param. It's been echoed into the panel namespace. That's a implementation detail. Strictly, it's not panel's problem how you connect things up. We just put it there as a nicety. So what this does is allows us to write a few functions, allows us to have one function that returns a plot, and then we do just the same thing we did before. We again called interact, we called find outliers, and we passed in this new function hvplot2 that just does a little bit more. It sets up this connection to the tap source. Otherwise, it's the same thing we were doing earlier. And so up to here, the left and the right are exactly the same things we were doing before. We had some variables, we had a plot. It's just like this one, right? Instead of viewFun equals hvplot, it'll be viewFun equals hvplot2. Otherwise, it's the same code. And then we added one more thing, which is to create this table. And this table just effectively filters your data frame. So anything you could do on a data frame, you could do in a function like this and display it over here. So we're watching the pointer x, y. We could watch anything we like. We can watch the y coordinate, the x coordinate, what data is selected. You could have a selection tool here, which it doesn't look like there is, but you could have a box selection tool, and the thing over here can be watching whatever it is you selected, or whatever. And that's how we implemented the things like, that's how this was implemented. It was watching the x and y location. This is also HoloViews based, this particular example. In this case, I don't know if this is still running, but it's watching a selection region. When I select a region here, every one of these four things is watching that selection. And whenever that selection changes, that plot updates, this plot updates, this plot. And that selection is actually a conjoint selection across all the plots. So there's a selection object, and anything you do on any of them goes into that selection object, and all the plots update when that selection object's changed. So if I want to look at only the things in Europe, I can select the European things that have a certain temperature, that have a certain precipitation, whatever. What's happening is that there's an underlying selection object. Each one of these plots is watching that, depending on that selection object. That selection object is also depending on the plots. So this is more complicated code to set all that up, but it's the same idea that you just saw. All right, so exercise 3 is on your own time. It just says, do something. You've already basically used the time because other people are waiting. But basically exercise 3 was just open-ended anyway. And then where to go from here? We already covered this section on deploying panels. And then you can go from there. We've covered interact and widgets. There's a totally different third way to use things that allows you to be completely declarative and never declare anything about widgets, but have everything also be specified. Use that if you want. And then just follow the rest of those. Pipelines is one particular thing to point you to. Obviously, it's dead end, but if you look for pipelines at the panel website, you'll see pipelines give you a complicated multi-stage app where you set some parameters, it does this, and you select here, and then you finally get to the thing you want. If you want that, it's an easy thing to do. So it can handle a much more complicated thing. If all you want is a simple pipeline of series of steps, that's actually pretty easy. So don't think of that as a hard thing, think of that as an easy thing. Everything else is hard after that. All right, enjoy. Thank you.